Hello students, I am Dr. Vipin B. Gawande and welcome to video lecture series for engineering graphics. In today's video lecture, we will solve the radial line development method for the pyramids. Now we will first understand what is meant by the pyramid. Now this pyramid means it is having the single base. So the base represents the true shape of the solid. Now here in this case, this is a pentagon. So it is having the 5 edges and it is having the apex. Okay, so this point is called as the apex. Okay, and the edges of the bottom base, these are joined with the apex with the help of the triangles. Okay, now since this pentagon is having the 5 sides, so we have here 5 triangles. So this is 1 2 okay, 3 4 and 5. Okay, so we have 5 triangles here. So in case of the pyramids, the front view is triangle, and we have seen in case of the prisms, the front view is what? It is rectangle. Okay, and the difference between these prisms and pyramids is in case of the prisms, we have two bases. Suppose if I am considering the square prism, so then it is having two square. One is here and another is here, and these are joined by means of what? These are joined by means of the rectangles. Okay, so here we have rectangles here. The first is, it is rectangles and it is having two the base. One is at the bottom and another is at the top. So that's why we have given here the two nomenclature. In case of pyramids, it is having only the single base and it is having the apex. So we call this as a apex and this is our base. Okay, and these are joined by means of what? These are joined by means of the triangles. Okay, so here we have triangles in case of the pyramids and we have rectangles in case of the prisms. Okay, now the front view in case of pyramid is triangle, the front view in case of the prism is rectangle. Okay, here we have to name twice because there are two bases, one is at the bottom, another is at the top. Here we have only the single base, so the nomenclature is only once. Here it is nomenclature is only once, here the nomenclature is twice. Okay, the name of the pyramid is based on the bottom true shape. So if here this is a square, so then this is called as the square pyramid. If here it is pentagon, then it is called as pentagonal pyramid. So here this is pentagon, so it is called as pentagonal pyramid. If here we take hexagon, then it is called as the hexagonal pyramid. Similar to the prisms also. Okay, so if the true shape is the base is the square, then it is called as the square prism. If here it is pentagon, it is called as the pentagonal prisms. Okay, the only difference here you have to remember, in case of the prisms we have two faces, one is at the bottom, another is at the top, and it is joined by means of rectangles. So here the front view is rectangle. Okay, so that you have to remember. And in case of the pyramids, we have only the single base and we have the apex, and these edges are joined by means of here triangles. So here in case of the pyramids, we have the front view is a triangle. Okay, so that you have to remember. The true shape may change. Okay, so here we may have pentagon, hexagon, anything. Here we may have the pentagon, hexagon, but the top view, the front view is always the rectangle in case of the prism and triangle in case of the pyramid. Okay, now we will start with the problem now. So the problem says we have the hexagonal pyramid of base side 30 mm and axis height 75 mm. Okay, so we have the hexagon something like this. Okay, so this is 1 2 3 4 5 and 6. Okay, so hexagon is we have a hexagon, this side is equal to 30 mm and we have given the axis, so that is 75 mm. So axis height, this is the axis height, so axis height will take here 75 mm. Okay, so front view, that becomes the rectangle. The front view is a triangle. Okay, in case of pyramids. Okay, so that is 75 mm. Resting on HB with side of base parallel to VP. So this condition is very important. Okay, we have given the condition, we have to keep that true shape of the hexagon in such a way that the side of the base, so this is the base of the hexagon, it must be parallel to VP. So every true shape is having two the positions. One is it is resting on the edge So this position of the hexagon is what? It is resting on the edge, and this position of the hexagon is what? It is resting on the corner. Okay, this is corner and this is side. Okay, now what is given in the problem? So for every the true shape we have two conditions. Suppose if we take the square, so then this is the side position and this is what? This is the corner position. Now so always draw two position and then check what is the condition given in the problem. It is given side of base must be parallel to VP. So if we take this position, that is side position, then the side, this is our VP. So here we don't have any side parallel to VP. But if we take this position of the hexagon, then this side, okay, this side is parallel to VP. Okay, because here we have VP and at the bottom we have the HP. Okay, so this side is parallel to VP. So the correct position of the hexagon for this problem is this one. Okay, if in this problem if it is given the side is perpendicular to VP, then this is the condition. Okay, so this is the position of that hexagon, because then 1 2 is perpendicular to VP. So this is the side perpendicular to VP, this is side parallel to VP. So we have to take this position as the true shape of the hexagon for this problem. So we will start with the true shape of the hexagon. So take the 30 mm distance in compass, then first construct the circle. Okay, now we have to draw this condition. It is resting on the corner, so draw the horizontal diameter. Okay, now keep the same distance in compass, that is 30 mm. Then from the two diametrical ends mark 30 mm on both sides. Okay, and then join this intersections. Okay, so like this. Okay, now this is the hexagon the hexagon true shape of the hexagon we have drawn. Now the condition is now satisfied. This edge is parallel to VP, because this is our VP, here we'll get front views, and this is our HP, here we'll get the top views. Okay, now in case of the pyramids, this in top view, this apex, it comes at the center. Okay, so it comes here and all the edges it joins with the apex. Okay, so if we take this pyramid, so this is our apex in top view. So this apex comes at the center here and all these edges joins with the apex. Okay, so how to find out the center of this hexagon? So you just join the opposite corner here and we'll get here this intersection. So in case of the pyramids, you have to join all the corners with the center. Okay, so okay, like this. Now the nomenclature. So nomenclature, suppose this is A, this is B, C, D, E and F, and this is our O. Okay, this apex comes at the center. Okay, and all this edges. Okay, which edges? So the line joining from the apex to the base corner, so this edge is called as the slant edge. Okay, in case of cone we have called that as a generator, but in case of the pyramid these are called as the slant edge. Okay, which edge is called as the slant edge? The edge which is joining from the apex to the base corner, so this edge is called as the slant edge. Okay, now we have joined this one. Now we will construct the front view. Now the axis height is 75, so first the projections from the center. Okay, so this is our apex, this is O dash. Now the remaining centers, the remaining projection, it comes only up to XY in case of the pyramids and cone. So this is the first, second, this one is third, and this one is fourth. Okay, now join this apex with the base corners like this, here and here. Okay, the nomenclature is, this is A dash, the front views are denoted with dash, this is B dash and F dash. Okay, this is our axis, this is C dash and E dash, and this is D dash. Okay, this is the axis, because no edge is here, so it is denoted with axis. Okay, okay, like this. The edges are coming here only, so this is A, B and F, C and E and D. Okay, so we have drawn the front view and the top view of the hexagonal pyramid. So true shape of the hexagon in such a way that the side is parallel to VP. Okay, this is parallel to VP, and the the front view is a triangle. Okay, so something like this. Now the next condition is, now we have to draw, it is cut by a section plane perpendicular to VP, inclined at 45 degree to HP. Okay, so all the in all the problems, the section plane cuts the front view only, and it is inclined. You just see the angle, so it is 45 degree inclined to HP and bisecting the axis. So this is 75, so take the midpoint of this. Okay, now at that point draw the horizontal. Okay, a small horizontal line, and then take their 45 degree angle. Okay, so 45 degree angle here, and then draw the section plane. Okay, like this. Okay, so this angle is 45 degree and it is at the center. Okay, so this is 35. Okay, so we have bisect this axis. Okay, and then we have drawn this section plane. Now after drawing the section plane, we know that we get the intersection, because this cutting plane or section plane, it cuts our the edges of the pyramid. Now where we'll get the intersection? So this is the intersection here. Then on axis we don't have the edge, so we don't have intersection there, here and here. So while marking the intersection, we have to be very careful. The intersection will get only on the edges. Okay, here, if here there is a edge, then we'll get the intersection, but you see here there is no projection from the hexagon, so we are not getting any intersection here. So okay, this is the axis only. Okay, so now I have told you how to mark the intersection. If one the edge is there, so this is a slant edge, only one is there, A is there, so this is 1. We'll take alphabetically. For B it is 2. Okay, F will take afterwards. Now here C, this is 3. Then for D it is 4. Then E, this is 5, and for F it is 6. Okay, so we'll get here a 6 intersection. For A it is 1, for B it is 2, for C it is 3, for D it is 4, for E it is 5, and for F it is 6. Okay, so and no intersection on the axis. Okay, if edge is there, so then we'll get the intersection, otherwise on axis we don't get any intersection. So 6 slant edges, and we got here 6 intersections. Okay, after that, now this is the radial line development, and I have told you for radial line development, the development, it comes on the development is to be drawn on the true length of the now here in case of the pyramid, there is a slant edge. So this O dash and D dash, it represent the slant edge. Now how will ensure that this represent the true length? If in top view, if OD is parallel to XY, then this represents the true length of the slant edge. Now see, in top view, OD is parallel to XY. Okay, this is our XY axis. Okay, so OD is parallel to XY, so then O dash and D dash in front view will represent the true length of the slant edge. Okay, OE is not parallel to XY, so O dash and E dash will not represent the true length of the slant edge. O dash and D dash in top view, OD, it is parallel to XY, so this O dash and D dash, it represent the true length of the slant edge, and the radial line development is always drawn on the true length of the slant edge in case of the pyramid. Okay, so we'll take this O dash and D dash as a reference. So from O dash, okay, now to keep your ruler scale on O dash D dash, this is our slant edge, true length of the slant edge. Then draw the parallel line. So this is our O and this is our A. Okay, now we'll construct the basic development. So take O as a center, okay, and then A as a radius, and draw the arc. Okay, now how much divisions here? So the divisions is equal to the number of sides of the solid. So here we have hexagon, so take 30 mm distance in compass. This is 1, this is 2, 3, this is 4, 5 and 6. Okay, now join these intersections. Okay, so something like this. Okay, so this is our basic development. So now this is B, this is C, D, E and F. Okay, and then again last is A. Okay, so we have drawn the basic development. Now if you remember, in case of the cone, we have drawn the development something like this, because that is the development is a curve. We have keep this curve as it is. Okay, but in case of these pyramids, we have the edges here at the bottom. That's why we have to join. Okay, we have to join this AB with the as a edge, or it is with the line. Okay, so AB, this is BC, CD, this is DE, this is EF, and last one is F and A. So you have to be very careful about this one. In case of cone, it is a curve, but in case of these pyramids, okay, in case of the pyramids, these are the edges. So AB is the edge, BC, CD, DE, EF and this FA. Okay, so this is the basic development for the hexagon. Okay, now we will transfer the intersections. So the next step is to transfer the intersection. So this is 1, this is 2 and 6, this is 3 and 5, and this is 4. Okay, so 1, 2, 3 and 4. This is for 1, this is for 2 and 6, this is for 3 and 5, and this is for 4. Now you draw the arcs from each intersection. So from here, this is first intersection. Okay, then this one is the second intersection. Okay, this one is the third intersection, and this one is the fourth intersection. Okay, now mark the intersecting points. So 1 is on OA, so this is 1. Similarly, this is 1. Okay, now 2 and 6. Okay, so 2 is on B, so this is the projection of these 2. 6 is on F, so 6 is on F here. Then 3 is on C, so this is 3, and 5 is on E, this is 5, and 4 is on D, so this is OD, this is 4. Okay, so we have marked the intersection. So this is 1. Okay, 1 and 1. 1 goes on OA, 2 goes on B, this 3 goes on C, OC, then 4 goes on OD, 5 goes on OE, 6 goes on OF. Okay, and the last one is OA. Okay, now I have told you, since this is the pyramid, so in case of the pyramids, we have to join all the intersection by using the lines. Okay, so the development comes something like this: 1 to 2. Now this is edge. 2 to 3. This is, we have to draw with the help of the line. So this becomes the A. 3, 4. Then this is 5. Then this is 6. And from 6 it is again, it goes to 1. Okay, like this. Okay, here. Okay, so this is 1 to 2, 2 to 3, 4, 5, 6, and then again 1. Okay, so this is the total development. This is the development for this particular section plane, which is inclined at 45 degree. Okay, so this is our required development. So this part is dark. Okay, this part is faint. This part is dark. The below part of the bottom part of the front view is dark. Okay, so this one is dark here. Okay, this part is also the dark one. Okay, so this is AF is dark. Then this, because these are the edges. Okay, 6 edges of the hexagon, which is at the bottom. Okay, like this and like that. Okay, so this is the required development for this problem. So you have to remember, in case of the pyramid, we have only the single base, which having the apex at the center, and all the lines are joined with the apex. Okay, if this is the prism, then we are not joining all the corners with the apex. Okay, so in case of pyramids only, you have to join all the corners with the apex. Okay, then the front view is a triangle. In case of prism, it is a rectangle. Okay, and in case of the cone, we have keep this core as it is, but in case of these pyramids, we have to join this by means of the lines, because these represent the edges. Here also, in case of the cone, we have drawn it by the core, but in case of the pyramids, we have to join it by the edges. Okay, or the lines. Okay, so this is the required development for the hexagonal problem. Okay, so complete the problem, and we will come up with the next solid in the next video. So thank you very much.